and Engineering College and Technical University Gujarat, Professor and Vice Chancellor. Thank you very much. Today I am going to talk soft computing technique to predict score around hydraulic structures. Yes, next slide, please. Okay. Due to high velocity jets, you can see this is the Salal Dam spillway in Jammu and Kashmir. Okay, what happened after inaugural function? This dam score takes place downstream. Why? Due to high velocity jets. You have since 8 decades the story since inconclusive. Whenever problem is poorly defined, then only this kind of neural networks, soft computing techniques using. Like you can also soft computing techniques you can see in share market. Actually, basically this soft computing means neural networks. Initially, they used in electrical engineering since voltage. Then later on, slowly in civil engineering. Now it's moved to almost all. Previously in 1990s in hydrology, since you all aware. Rainfall to runoff, simply like black box model. Okay, then later on some flood predictions, then slowly in hydraulic engineering, hydrology to hydraulic engineering, especially for Scour around hydraulic structures. In 1993, Trent and Day, initially they have developed for peer score model. Today also I will show some of the my student work, peer score and abutment models and score below pipelines also I will show, and culvert score. Okay, next slide, please. Okay, you can see ski jump bucket operation is after inauguration. I think in 1988 and around that time. See, right bank due to high velocity jets, right bank damage it happened and the score takes place. You can see previous slide. All white water. Now you can see all with sediment. It means score takes place downstream. Okay, within 1 day. Okay, next slide, please. Yes, see this much 1,50,000 cubic feet per second. This much they released flood water. You can also see here the jet is impinging very near. So this safety concern very problem. Okay, next slide, please. Okay, you can see clear picture after. So this is the problem still poorly defined. There are several formulas since 8 decades, 9 decades. Means European hydraulicians and Dr. Damble from Central Water and Power Research in Pune. They have used some parameters which I will show you. Okay. Next slide, please. Okay, this is the one of the dam from South India, from my state, Srisalam Dam. Here, what happened? Some lip angle. What this all problem? You can see theoretical jet. We think very far, but theoretically, but in reality, model and prototype and conformity takes place. That due to air resistance, you can see clearly observe. Here, what happened? Lip angle. They consider, I believe, 30 degrees. So jet is falling immediately see downstream of the bucket. So they have problem whenever rainy season. Recently Dr. Mehta shared Ukai Dam also. I will show that slide also. Okay, so this is the major problem for hydraulic engineers. Okay, this is the about dam. Okay, then another due to horseshoe vortex, so you can see here bridge pier score takes place. I will also share here in Caribbean islands few bridges is totally wash away. Especially during Christmas time, 2009 and 2013, due to horseshoe vortex. This also whatever shape there. I will show some photographs also that also. Okay, next slide, please. Okay, this one, this means just for energy, how much, this much energy about river, this Brahmaputra river. Okay, next slide, please. Okay, so during river mechanics, this slide came. Okay, next slide, please. You can ignore. Yes, the river have one geometry, that one. Okay, next slide, please. Due to river mechanics. Yes. Okay. Yeah, another you can see here one of the island here in 2013. So culvert due to see dissipation of energy, culvert failure happened. Why this happened? A culvert structure, that which you all aware, right? Culverts in roads, railroads, you know any obstructions means when natural river, so it's okay. Whenever you build either these bridges, so many piers, the constructions, then it takes score takes place due to obstruction of water. Okay, okay, next slide, please. So, okay, you can see here the Saint Lucia, one of the Caribbean island, and during Christmas. Okay, this was a failure of culvert. You can see so much damage and totally nothing there. So there are so many regions. Normally, any structure, 35%, 40% hydraulic design failure. So many, but still problem is we can that poor design. Okay, next, please. Okay, here see bridge failure in Jamaica, one of the another Caribbean island in 2009. This was so you can see bridge. No pairs, nothing, everything wash away. That's why we say river energy. Okay, next slide, please. This one. Okay. No, no, this one. Okay, you can ignore this slide. Some peak flow and urbanization. Okay, next slide, please. Okay. Yes. See the local score. The different shapes. You can see circular, square shape, and I will show some more. So in river engineering, this one highly concerning. Whenever see this fluid structure interaction, you can see in upstream side to horseshoe vortex score takes place. Okay. So score takes place. So whatever site you can see maybe Professor Mehta done many works, parallel bridges and all using HECRAS. Recently, I attended and still attending one of the hydrobid software. They are arranging our university and one of the very new software. They also and they're predicting this core depth and all. But I still believe model studies is one of the option. One of the option. So this is the thing how to protect and many papers you can find many papers, but there is no suitable even Hecate formula and I have also published in 2010 AC hydraulic engineering same peer score using all field data field data okay. With the simple techniques. Okay, this one score and how it migrate. Okay, okay, next slide, please. Okay, another bridge failures in Saint Lucia. Same, see, you can observe in 2013 how much is, in Caribbean islands what happened. You can see completely no structure. You can see everything wash away. Yes, there's another collapse of the bridge. I believe another island. Okay, next slide, please. This one I have taken from one of the I think Chinese. You all observe right now if any in China any floods, they will take everything like disasters. Okay, this one almost 10 years ago. Okay, another this one same mechanism how show horseshoe vertex and all showing. This is about see you can see now three structures, bridges, culverts, and spillways. I have shown to you. Okay. So mostly you can see all the in hydraulics all aware, mostly fraud number and how much flow depth and discharge, only three different factors and sediment size. Okay. Okay. Next slide, please. Okay. Yes, one of my student from Pakistan, I think. See, he conducted some experiments. See, initially with in Flume, he conducted with circular pair and square pair. And also you can see how score the techniques observation. Next slide, please. Yes. Now see what his idea. The third pair is slightly exactly like orthogonal what we think. So the score shape you can observe which one is most, and this work he published in hydroinformatics in 2012. Okay, this one Parvati dam spillway model 1:15 scale model, which is situation. Can you play this one? Yeah, somewhere. Yeah, yes, thank you so much. So you can see here, now this one stage two. That's why I showed previous slides. There are say, even Tista, several stages. We are all aware, right? National hydroelectric projects in northern India. You can see this one upstream side with the three spans, and also you can see power intake here. Power intake. Please play. So upstream, at least 2 3 kilometers, we have reproduced that time. I worked there in 1998, almost 20 years ago. So this one upstream view you are watching now. You can see here strong vortex will take place in span number 1. So water level measurement. You can see here power intake. So whenever you want to operate reservoirs, especially for power generation, you have to have full reservoir level. Here you can see jet is directly hitting to right bank. See, even in model only you can see the thickness of jet and velocity. So and this another spillway model. Okay. Thank you so much. You can see here the strong vortex will take place, and full reservoir level. I still believe to 198 the elevation. So such a thing, and also gated operation. Whenever gated operation, the throw jet downstream very high. So something benefit, something we have to have score downstream. That one, no doubt about that. Yes, you can show Dr. Mehta for your students how vortex takes place. So this one mostly breastwall type of spillways. Yeah, this one confetti I have used that time. Okay, no problem. If video due to internet. This one another dam spillway Doringa, which is my first model. This one 1:70 geometrically similar model. You can see this one Rockville Dam, whether right hand side or left hand side they will provide, but here right hand in flow direction right hand side. Okay, this is a very long chute. You can see this all NHPC projects breastwall type of spillways. Like the small opening at the bottom like sluice. Okay, you can also see near me here. Here you can see rooster tile forming. I mean, in front of pier. This one. Then you can also here also same problem means high velocity jets and right bank. So previously Parvati Dam spillway. Then the my boss, Katsura Sahib, we suggested dam axis should be changed. Then only we can save right bank. Okay. Otherwise safety concerned. Here you can see next slide, please. Okay, this one you can see, when I worked, I left 2006, 2005. So three spans. Then again, you can see here the three inside two spans. What happened? The training wall they cut it, and you need protection, right? Especially for scoring. So water should be like spray, And also, I designed this one. I'm very happy to say this one. Deflector that time. I was like Dr. Mehta. After MTech, I joined there, and later on, I did my PhD from IIT Bombay. You can see prototype also here. This one, I think, I believe 2013. This photo. So the time also you can see an upstream here also. My boss suggested that time to them some problem will happen, so it happened. You know. But in this one, I worked in high head structure, so this one all rigid one. Another division there, that one flood control division, they will put mobile bed and also much sand to release and reservoir capacity they do. But I considered only this one spillway capacity and what are the velocities and pressures and also reproduced with scoring, bed model with mobile bed material. Okay, next slide, please. Okay, this is another one. I have always collaborate with Iranian research. See, this is the one of the art you can see in Pune. I have worked with all with the cement mortar. Here you can see perspex sheets. So this is the another flow phenomena, especially any researchers. Each model you can see. I have worked with them. Okay, this is the another art. Means physical modeling is one of the tool. Okay, best tool. It's a flow phenomena, very easy. You can see in model only one of the picture throw distance, how much very far. It's more than 2 meters and all. Okay. Okay. Next slide, please. Okay. So no, come back to here. The today I will talk almost all the structures, mostly fraud number criteria. So spillway means main purpose of spillway, either to dispose flood water excess in capacity, reservoir capacity. You can see okay dams clips also. Dr. Mehta shared to me a few months ago. Will show you. Then how how you control. To get an operation only this one mostly the type of dissipator is another challenging job. Many like Sardar Sarovar, you have maybe stilling basin, which concrete it take more, and also during construction in Sardar Sarovar, especially water surface profiles, maybe due to aerators, all blocks, gone. That time they have faced so many. Then in Central Water and Power Station, they analyzed and with how much forces acting using transducers. Then here I have considered ski jump bucket, or here in USA they called flip bucket. In Europe they called trajectory bucket. Mostly you can see. Okay, next slide, please. I will show you simple design. Okay, here you can see observation upstream side reservoir level. You can see this one the crest. The problem is many researchers this one consider this reservoir level 2, this one tile water level mostly this consider H1. But in case of Dr. Damble's formula from Central Water, he consider until here only head means lip means water is throwing from here, so he consider. But I have considered in my research tile water level to the difference between reservoir level to tile water level, that one head. And also you can see, so where this one mostly we have mostly in teaching you say wherever strong hard rock available and tile water level available, then only you will go means so anything the another challenging this one. So only due to high velocity just a score takes place. Why this one rate of change of momentum equal to force, you'll see whatever radius there and lip angle. So you all aware in high schools, you have to means the maximum range if we want range equal to u square sine to theta by g, means if theta 45 degrees we think it will go very far. Okay, so score takes place due to high velocity jets downstream of the bucket to prevent uncontrolled score of this banks. So only two alternative away. So one is pre-excavated plunge pool. That one very expensive, but there is no choice. The another one rising tile water level by constructing VS sufficiently downstream side. Okay, two alternatives. Okay, next slide, please. Okay, here, see this one. You are looking at Subhan's reaction. So many, in model only you can see how much this jet thickness and all. So estimation of score can be classified under four general groups. Theoretical analysis coupled with laboratory investigation, theoretical analysis coupled with prototype observations, empirical relationship based on prototype observations and laboratory experiments purely. Okay, next please. Okay, so this is the you can see for Parvati Dam spillway after conducting experiments. This one's a gated flow. Whenever gated flow, your throw distance will be very high. Okay, compared to ungated flow. Okay, this is the proposed elevations. Okay, this one I believe 2198 will be this one. Yes, yeah, 2190 full reservoir level. So such a high head structure, that one. Okay, so this is the this one, as just now principal sir told, right, origin software. In that time I am very familiar. I don't like Excel, so this one origin software I used, and I have plotted this profiles, other such profiles, how where jet is impacting. Then you also provide this. Till now no one had done so many reasons. I will show you. Okay, next slide please. So different discharges, 100% discharge, 1850 is the maximum proposed, then 75% discharge, 50% discharge, and score elevations from model. Okay, this kind of things I have used for, like this. I have collected 95 sets from, means I have worked 6 years, 6 years there, and I have collected data. Only collection of data, only very laborious. Only that time, the major contribution means all time gone there only. So this is proposed plunge pool for ungated flow. Okay, next please. Okay, yes, you can see. Previously I was telling, right, it's a strong vortex you can show to your students here. Immediately, you can see here power intake there. Okay, this much. Okay, 2198 full reservoir operating. So the factors can that predict prediction of depth and pattern of score hole, what discharge intensity, any structure you can see, and the head. This one, this horizontal jet, tile water depth, lip angle of the bucket, radius of the bucket, and particle size, and rock quality designation, and rock mass rating. Several formulas, means almost see here, almost 90, means 8 decades, right? 8 decades awareness used, and Damle, very simple. They used only discharge intensity and head as input variables. These all formulas. Then they proposed. But in my case, my research, I have considered depth of tile water level, lip angle of the bucket, radius of the bucket, and also bed material, which is very important. I will show you as now, just now, your principal sir also told how data if erroneous, how we will use. Yeah, I have 10 slides. I have. Thank you, sir. Okay, next slide, please. Okay, see here, you all aware, right? Ukai Dam, since I believe this one from Ukai, if state is not separated like Andhra Pradesh and Telangana. Okay, so the awareness formula produced, 18 meter, while observed score was 27.4. In case of Rana Pratap Sagar, awareness formula, 18 meter, and then observed score 24. Means there is no matching, and either over prediction or under prediction. In case of Kariba in African Dam, Zimbabwe, awareness formula. This is the awareness formula. Still, Bureau of Indian Standards and United States of this one Bureau Reclamation, they are both using same formula till now. I don't know. They appreciated the time, my paper and all. I really don't know whether they updated or no. Till okay, so discharge intensity and head only they considered, and the formula which is one, then the prediction using this formula. So this one simple empirical formula. Okay, you can also see how much I just want to show 0.54 for discharge intensity. You all aware, right? It's unit discharge or specific discharge, means discharge per unit width, and head, as I told before, reservoir level to tile water level. This is H1. In case of Damleser formula, that's different. He consider until head, until lip angle, lip of the bucket. Okay, next please. Okay, here the regression models initially I have developed, and also as I told, I have conducted several model studies. Okay, then these are the my input parameters: discharge intensity, head, tile water depth, lip angle of the bucket, radius of the bucket, and bed material. And see, mostly all other formulas they have given only depth of score. But in my research at that time, I have provided core width and location of score, which is if you want to propose any plunge pool, you need this all as engineering. Okay, next please. So these are the my inputs and outputs. You can see here. So this one downstream bed I reproduced with. movable bed material. You can see exactly. Okay, you can also observe this is the dam axis, right, from here to until many kilometers. Okay, exactly, even upstream and downstream. So very laborious. That's why these models are still we believe these all fraudulent models. You all aware. Okay, next slide, please. You can see upstream view. This is okay. Exactly, you can see how this one power intake. Three spans here. Okay, you can see before and after. So you can see score hole where in model only, trust me, model only this much distance and score taking place. Okay. Okay, next slide, please. Okay, see here, even in model only. So the jet was hitting here. So finally, we suggested only option dam axis, tilting of dam axis. This can solve this problem. Okay, next, please. Okay, here you can see even here see sometimes with here rounded circular here, right? This is the rooster tile and also that also joining. See, this is the throw distance. Okay, many asked me how much means angle, lip angle, whatever they means 30, 35. My boss, they have more than 40 years experience. They also used to tell 38 degrees. 30. This one again I say model and prototype conformity due to air resistance. That's why Kawakami, Japanese engineer, have conducted. If you say your jet is 100 meter, but due to air resistance, it may be 80 meter only. 80 meter only, but how your energy should be dissipated, that is the only challenging. Okay, challenging, and you need to reduce scoring. Okay, next please, score depth. Okay, here you all where this one, Bayesian of Buckingham Pi theorem. It's a depth of score is a function of all my parameters, and similarly location of score and width of score. Here I face a problem only width of score means a lateral energy dissipation. I face okay. In choosing some repeating variables, I have formulated like this. Okay, next slide, please. Okay. Okay. Here, depth of score with relatively, I considered. So many they consider maybe they take a H here, but I consider the tailwater depth is very important. It's, if anyone in water, if you throw something, how much you're hitting. So the Buckingham Pi theorem, from this one fraud number. Okay, this one relative head, then this one with bucket radius, then bed material and tile what depth, and this is the constant you may remove since all with only the civil engineering which consider only water and this one density, then 5 lip angle, then width of score, then location of score. Okay, then I have 95 set data. I have considered 75 for training, even for regression models. I will show you next, please. Okay, see here, as you told, there's no statistical. See, you can see how much importance 0.94, this one fraud number. Okay, this one relative head. Okay, bucket radius. You can see inversely. Okay, this one. That's why always we see this one lip angle also very important. In case of location of score, you can see always here 0.34. Okay, that's what I observed, and also always this one always no, a fraud number important takes place. That's why I will show you also perturbation analysis if data is erroneous. Oh, okay, next please. Even these equations, using least squares, I have derived. See here, see, I got negative due to lateral energy. Since my jet is like this is direction, then lateral energy dissipation. So some you know uh, funny answers and while publishing so many questions, but no one asked at that time. Okay, simply as English corrections only, this age was the okay. Here you can see width of score, the perfect, then radius, then lip angle. See, correct your flow direction, your jet direction, so it's okay, negative. Okay, next please. Okay. Any models, regression models, anything, you have to have some error measures which before you generalize. Here correlation coefficient, but it's a very sensitive, linear relation between observed score depth and predicted one, and also root mean square error. Next. So average error and average absolute deviation. These four error measures I have considered here to generate whether model is okay or no. Regression. Okay, next slide, please. Okay, this is the some error measures. You can see still, my correlation coefficient 0.884 correlation coefficient. If R square coefficient of determination, again, it's not gone beyond 0.7. Okay, in case of especially depth of score, location of score, it's okay, and width of score, okay. Okay, so okay, next scatter plots we will see how. Yes, see, still some outliers either over predicting or under predicting. Okay, this one perfect line between observed and predicted score depth. Okay, okay, this one relative depth. Okay, this one observed versus predicted. For width of score. Okay, you can also see some for lower range, it's always under prediction. Okay, this one all for testing, which I have not used during training, means for regression model derivation. Okay, next please. Okay, here almost you can see location of score, many one outlier. Okay, then many. Okay, under prediction. Okay, this is your best fit perfect line. So although your correlation coefficient one means r square 0.83 or something will come, so still um we need to have either neural networks or gene expression programming or some advanced. Okay, we need to have. Okay, next please. Okay, another thing that was previously I showed for model. This one, uh, using proto data means real data. I have collected 93 data. You can see I have plotted if there are any relationships. Since many, you can see Verness, Damle, Vincent, and Wu, they used only two parameters: discharge intensity and head. Okay, then depth of score versus discharge intensity. I have plotted. You can see there is no relationship. So if you draw perfect line, either again same, so much random, highly random. Okay, next please. Okay, see here also same, if I head underscore depth, there is no relationship. So what we can do in this case? So I have used that time. I also derived regression model as well as neural networks I used. Okay, next please. Okay, yes, typical, I'm showing, with two inputs. This is nothing but neural network means nothing but it is technique to map random input to random output. Okay, what here, how we decide, training data and testing data. And if you use MATLAB, just now sir also told, MATLAB means, sorry, here very hard. This especially tropical country. So two inputs. If you have data 100 points, 100 data sets, in MATLAB they will do training for 50%, 25% testing, another 25% for validation. But I have used here 75% for training, 25% for testing. I believe that time, 93 I got. Okay, this work I have published in IAHR, Journal of Hydraulic Research, which take many years. They lost my paper, and finally, that time not online. He lost, Professor Garcia stable. Then finally, I got this paper in 2006 after my PhD. Okay, next please. Okay, here can you go back, please? Just I will explain some more later. Sorry. So here you can see this theta is sorry, not that theta. Here, bias, and this are the connection weights and bias means input multiplied with weight plus bias. Any through transfer function. That is the neural network's simple definition. Then again, several architecture. There's this one, the feed forward, what we call feed in your data forward network. At the same time, then if you this network, slow, very slow, but it will give very accuracy, means error is propagated towards backwards again. Okay, some schemes I will show you later if time permits. Okay, so only one output here. You can see I have data, that time proto data, real data, only depth of score I have. So this layer, hidden layer, means I have used only two hidden nodes. That time I used this one Stuttgart node network simulator. Later on, we have MATLAB, many softwares came. Okay, many using. Okay, this one again, people means all any researchers, any engineers, they say black box models. Why we need to use? Many comments will come. Okay, so especially designers, they criticize. They need, you are giving only matrix and matrix of this weights and bias. Then capture that matrix and testing. It's one no, very not perfect. So they don't like, especially design engineers. They need to have equation which I show you. That one. Okay, next please. Okay, so here you can see here feed forward backpropagation algorithm, feed forward cascade correlation. Then MATLAB I used just now. Dr. Methods are told, right? And if it's adaptive neurophagy information, this which is very powerful. But again, many rules it will produce. This one really basis function. Okay, three, four only I'm showing here. You can see almost all. Okay, not bad. Still acceptable. Okay. Okay, but some only some either under prediction or out some outliers also there. Okay, any. Okay, next please. Okay, these are the traditional formulas still now we are using. You know, this one Martins, Vernes and who and all. Why I have not considered here Damle's formula, since I don't have data. He considered the head will be reservoir level 2 or lip. Okay, that's why that's the major difference. So I wrote, excuse me, I wrote many comments also, many researchers from other institutes. That time they use data, my data, and all. They don't know even H and H1 the difference. So myself and even Professor Katsuri also wrote comments. So whenever you are producing some paper or something, it should be acknowledged, and also it should be very clear. You can see my comments, even general hydrology. That then only I become even though I'm hydraulics, they invited me. Sometimes funny results author showing and all. Even though, so very carefully. Okay, here. So this is their formulas. Okay, you can see correlation coefficient very less. Okay, this one observed to predicted. Okay, with respect to perfect line, you can see many outliers. Okay, okay, next please. Okay, so this formula I have developed using same data with a range. Okay, then you can see here compared to inset and this head, this much h1 power I got this much depth of score. Okay, so this is the my scatter plots. Still I have some underestimate values, right? So only so problem remain inconclusive. So I have used neural network that time. So four algorithms I have showed feed forward means this feed forward and also supervising this one. They say learning type means you are giving output, you need some target you are producing, and also you can see in model you can fit how much error you need to, means mostly we cannot put zero, but still some acceptable results. Okay, this is about prototype data I have used, and this work I have published in Journal of Hydraulic Research. Okay, although it took 5 years. Okay, next please. Okay, you can see these are the results. Okay, neural network models. The why we using these models means this one empirical formula still fails. So radial basis function ANFIS. Then later on I will share to Dr. Mehta. I and Dr. Aitagwen in 2013 we have gene expression programming and all. Then we produced another paper. Gene expression programming, which gives very good results compared to this. So these are the errors. So regression means this one my equation, 0.77 it gave. Okay, next please. Okay, this one for models for hydraulic physical hydraulic model data I have used here. Okay. So training, you can see total I have 95. So I have so up to me means many they say how we decide and all. But if you have more data as for like MATLAB, you can say 50% for training, 25% testing, and another 25% you can for validation. Okay, okay, next please. You can see here the typical structure I will show. Oh yeah, I'm showing almost all sequences score papers. All I will share all my papers. Mostly all same. That's why one of the unknown author they commented how like this model, the structure same. And also procedure everything same. This is the input layer. So you can see raw variables I have used. That's why Liriano and Day the another HR paper that time 2003. They produced one paper. Then here you can see one of the beauty of this model, depth of score, location of score, and the width of score. This one looks like continuous model. Even you are like a numerical model, it works. Okay, so almost numerical model only, but it will give perfect works as a. Otherwise, another my students, Iranian students, they use CFD modeling, which is showing only depth of score. You know that's why this is the another advantage. Recently, I attended this Hydrobid software. They are showing another thing, but I still believe, this kind of work. Okay, this is the unsuccessful. Mostly many researchers. Okay, this one using raw variables model one. Okay, next please. Okay, another one you can see what I got from dimension analysis. So fraud number, relative head, bucket radius, and only five. So when using MATLAB and my matrix size is reduced, and you can also see everything relative to. So relative depth of score, location of score, and width of score. Okay, so this one dimensionless parameters. So the time I developed C score software in this work published in ASE Journal of Hydraulic Engineering in 2005. Very fast at that time, only 3 months. In 3 months, it's published. Then they asked me to submit a PhD, but in we always competitive exams we attend. And then later on, finally I got degree. Then I moved to National Taiwan University, Taiwan. Okay, next please. Next slide. Okay, this is the architecture of model. You can see model one means raw variable. So 6 inputs, you have 10 hidden neurons and 3 outputs. You can see time, as I told, back propagation algorithm. Um, Actually, this one back propagation error propagation algorithm, they will say. So 900 seconds it taken. So you can see RBF very fast. Even if ONFIS, that one more fast. So I write code that time. This first through algorithms used Stuttgart neural network with same data, whatever training data I used, same thing I have. But another laborious, whenever Stuttgart neural network simulator, need to write in again C language and how to need to data upload. This one German software, okay. In IIT Bombay, they were using provided that time. Okay, next please. Another model you can see here. So time reduced and also matrix size. Okay, hidden neurons. Okay, this one CPU time. Okay, here see RBF very fast. Okay, next please. Okay, this is these are the results. At least you can see some predictions here. You can see cascade correlation means here each network what happened here the hidden neuron each will be adding until you get good results. Okay, then you can stop your training. When you will stop means you need to generalize. What happened? This kind of fast algorithms always stuck up in global minima. That's why always backpropagation algorithms even the slow that you can suggest. Okay, we'll also show prove that these are the not black box models I have as I will show you now. Okay, next please. Score depth, this one location of score length. Okay, then here you can see evaporation worked very well. Okay, next please, especially model 2. Okay, then width of score. Okay, that's also approved. Okay, only depth of score cascade correlation approved much better. Next please. Okay, these are the results. You can see results means always which model is good. So then again, uh, uh, you must have to have error criteria, correlation coefficient, average error, mean isolation deviation, and root mean square. Okay, so that time we suggested model two is this one, this model. Okay, even reviewers are agreed that time. Okay, next please. So this is the suggested model. You can see weights and bias. Okay, I will show you matrix later in future slides. Okay, so 5 inputs. Okay, Next, please. Okay, so how significant? Okay, an attempt, made. I made even sensitivity analysis. Okay, on some combinations. Okay, next in table I can show you very easily. Okay, you can see initially, I used two inputs as previous traditional researchers, old researchers, they used discharge intensity and head. So how your error, root mean square error and correlation coefficient. Okay, then you can add, but middle always we must consider, and also depth of tile water level. Then also I used see why rate of change of momentum equal to force means that much force on water hitting the thing. Okay, project. So bucket radius also important. Also lip angle observation means how much far, especially for your location of score, and also how impinging jet means many papers you can see jet another many researchers especially Nallamuthu Rajaratnam from Alberta University. Okay, and done many even Professor Pani from IT Bombay means ex professor, previous professor. Okay, they another sorry, how much equilibrium length and all, how much then jet. So that's beyond today's lecture. Okay, so finally, if I consider all this, then six raw variables. So this is the results I got. Okay, in case of model one, feed forward propagation algorithm one. Okay, so that time my contribution of physical models that only many American university even here if you conduct that's enough. More than that you don't need to do this one another this one like it's also laborious. Answers will never come quickly. Trust me. Answers several nights and training that time Stuttgart now advanced softwares came as principals are told. So very easy for my students. If you go today, they will produce tomorrow. But you need to have cross check, double check. Okay. Next, please. As students are very brilliant right nowadays. Okay. Then two inputs you can see using grouped variables. Earlier I have used raw variables. Now I'm showing you grouped variables. These two. Okay. Uh, Then you can see the fraud number and also head, which and they're very important. But you can see slowly, you can see error is reducing. Finally, here you can see error. Then what correlation coefficient? Sometimes whatever I got, I put. I did not manipulate it here. Okay, that's what I many people say. Here 0.7, here 0.248, but here okay. Sometimes whatever I got, I did and I have compared. Okay, this model too. Okay, next please. Okay, this yes, this is very important. This is what I want to show. Which this neural network model is not black box. Okay, you can see relative importance. It means ATC Go just now as I told. In civil engineering from Singapore University, actually in Singapore he done for geotechnical engineering. This kind of work. Then later on, same time I also parallel done. Okay, in case of C discharge intensity, this one hidden neurons and your connection weights. Okay, this is the then calculated, then relative importance. So how much? 37%. You can see. You can go back to your regression equations. You will prove. Okay, next please. Then I can show you the yes. You can see. Go back and almost. So the relative importance. Okay, this much came. Okay, next please. I also done if data is as sir told just now some parametric studies means this one even though they are myself at that time asked in model means physical it are not in mathematical model you can in laptop you can do anything but in physical model keeping one and change all means only we need to go workshop and change this spillway profile changing the radius and all totally become mad why I take civil engineering that time I realized. Okay. Next, please. Means here, see, keeping one in parameter and change another one. Yes, here you can see how results. We all are aware if more head, more score takes place. See here, score increasing. Okay, score depth. Normalized score depth. Okay, then discharge intensity also same. You can see if intensity more, score depth also more. Okay, then reverse relationships. You can see phi angle. And also you can see blue, which one? Yes, if bed material, more big boulders. That's what the another challenging issue for any hydraulic engineer. So this will give only pattern. That's what my boss has also told, which those have 40 years of experience. To be frank, I worked only 6 years so in a hydraulic lab. Later on, I moved many countries, and some places I never teach, water resource engineering. Since basics, fluid mechanics, so don't teach fluid. Okay. So, in the case if bed material, that's why I told in scope of study, rock mass rating and rock quality designation is much important. You can see in proto big boulders, you can see, and also depth of well water level, you can see here. So that's why the how plunge pool importance. Okay, next please. Okay, now as principals also told, if erroneous data, what will happen if data is noisy? Means error measurement positive or negative 10%. How your results will affect? So your especially correlation coefficient, your error. So this is what is called perturbation analysis. So this paper also I have published, almost 6 years ago. Extraction of knowledge from trained model. For Calvert score, I have done Calvert score. You can see all procedure, everything same. So now second year level, second year levels. That time when I study numerical methods and also fluid mechanics same, Buckingham theorem and all same. Means not gone beyond. Now I don't know either methods are ready to tell. They are studying, your student study C++ or advanced any software engineering. Means languages. I mean second year or some university they will allow final year. Here, unfortunately, we have only 3 years. Still, like British era, only 3 years degree. I totally become mad. Even student also like now semester wise, you all aware, right? Very fast, like fast foods. Go and get degree like that. Our time, my time, yearly pattern, yearly, very good, and external examination. Now all we are all only other than accreditation, nothing. We are doing no research, nothing. Only accreditation. We also have from here London. So same thing. Otherwise, in Saudi Arabia, when I was there, a better accreditation. Only accreditation, NAC, maybe you also same. Okay. No research, nothing. Always, all time, only paperwork. How student wrote, how you feed it them. So this is the story. So here, erroneous data, how error vary. Okay. These are the combinations. Okay. Next, please. You can see here. Yes, please. This one pattern analysis for model one. How you can see correlation coefficient for especially depth of score. Okay, location of score and width of score. Okay, how? No, just now sir told right. So exactly my slide is matching. I'm very happy. So if erroneous data, how it takes place. Okay, that's what that is the beauty of these models. This soft computing. Okay. Okay. Next, please. Dr. Mehta, is time is okay with me? Hello? Okay, so here you can see also ranges H hidden neurons until 10. So whatever captured this one, see you can see capture, and again you need to type like this means you almost totally become mad. No, this one. That's why this one black box and much irritation. But what to do? Okay, next please. Okay, this one another correlation coefficients output, and this one see hidden neurons each. Okay, or in case of relative score depth I have worked. Then also later on, yes, no problem. Next please, next please. So ANFIS, another technique, neuro fuzzy inference system. The time I, Dr. Londes are also giving. So he was my local guide. Means he helped me. He taught me MATLAB. I was like, what to do? I don't understand anything. Means daytime all, that time I worked only hot sun, only physical model, no office, nothing. Now all everything AC rooms maybe. That time only daytime like field how the same proto same way. So that time, then he taught me this one ANFIS, neurophagy information system. This one, this okay. Next, please. This one, like your washing machine. If then else. So here, whatever model proposed in neural networks, I will do the same thing. Okay. Here model two, since metric size always important. So fraud number, this relative head, bucket radius, and all. Here problem is only one output you can use at a time. In coding, they are like continuous model I can use, and I produce depth of score, location of score, width of score, so that you can directly give your plentiful geometry. Okay, that is the story. Okay, next please. Okay, so this is the model. You can see here the inputs, then some membership functions, then some rules. Here two rules output membership. Later on, I worked for sediment load or something for one of my Chinese student. He gave me 50 rules. Then I totally, so that's why this is the disadvantage. Sometimes only rules. What the designer will do, you tell me. Okay, so this is the output, only one output at a time. So we need to for the allocation of score again, then width of score again. Okay, next please. Okay, you can see now perfect match almost. Only lower range, some problem, lower range. Okay, lower range. Okay, the correlation coefficients also okay. R square means almost good. 0.86 or something will come right. 0.89. Okay, next please. Okay, here also this one location of score good value. Okay, next please. Okay. So this is the procedure. Why I am talking today? Thanks, Dr. Mehta invited again. I'm showing maybe same sites, but similar. Only procedure this much. But one guy, you also always have some enemies. When I got promotion in Malaysia, almost 5 years it taken, not very early or something. Then used to I am already editor. The email came to all. It's all same model, same methodology. So then I ask. My referee from United States Geological Survey, Professor Jarrett, he reviewed my papers. He helped me a lot, and he guided me. So in America, we call this one hot boiler. When engineers write or any modeling, we cannot change much. Even writing methodology and thing. Okay, especially score. Okay, next please. Okay, this all I have discussed in parametric analysis, right? Expected. Okay, higher values. So these are they can see. These are the results for. Okay, you can see. So increasing in the lip angle may result higher depth of score due to increasing height of the jet. Total momentum remains almost same. Okay, that time keep change that this means in physical model, not here we can do anything adding and decreasing, but no, my boss want purely in physical modeling, then the same physics. Okay, next please. Okay, this all observations with neural networks. Okay, so this then you can see here how linearly separable and all I have shown, right, like regression. Okay, these are the advantages. Okay, next please. So some codes I will later, if you want, I will share with Dr. Mehta. Okay. Then those time even Londes are also teaching, right? So some codes, how simple codes. 10. When he taught me, he gave simple code. Like straight line y equal to mx plus c. Okay, he gave. Then 1 to 10. Then he gave. So how that giving, especially in MATLAB, very easy. Very easy, but only thing is time consuming. Only this will become increase. That's all. Okay, so 10 line code I will share it with his permission. So he taught me. Then I worked. Then I developed a C-score package using MATLAB. Okay, very same, either Calvert score or bridge pair score, or now I will show you few more for score below pipeline. My another PhD student done in I developed a hydraulic model, physical hydraulic model lab also in Malaysia. Okay, next please. Okay, this one on the time. Still, I have not continued to work here, and that also very difficult to get. Also, you can see additional hydraulic model measurements. Here also we have very small laboratory. Okay, and latest tools means I have used gene expression programming, which available GEP and even GEP, many almost same like a tree based, and many other softwares. My students recently we submitted another paper. Okay, okay, next please. The tools. Perhaps now bring back to here to you all the another problem. This one especially in Caribbean island. This one Trinidad map you are showing. Only oil here gas line. Okay, natural pipe. Okay, next please. I will show you. So one of the pipelines, see, whenever see here, mostly Professor Day and Liriano, and also a few researchers from Nanyang Technological University, they also done for pipeline score. This one you are okay. Gas pipeline and how much where it should be. Okay, or below pipeline. Okay. Whenever this I published a paper in at that time I was in ASC pipeline systems engineering editor. Then only one or two papers I published. Otherwise, again same like Asian mentality, right? I was working there, so he's editor, he publishing. So I never again. Okay, so here you can see underestimation of river bed. Okay, so where river pipe should be. Okay. Okay, next please. So here I have not considered vibration or anything. I will show you. So this is what will happen. Okay, so okay, this slide I taken from Professor Srivastava, who works before me here. Okay, it's from IIT Kharagpur and IIT Delhi, and his PhD from here, University of the West Indies. Okay, next please. Okay, this one another physical model. You can see this one, Perak State in Malaysia, where I worked there. You can see river model. One of my PhD student, Muhammad Adlan, is it's also very similar. Means developing physical hydraulic model. Okay, next please. So he all 4 years, 5 years gone. Okay, here you can see the model development. Okay, section and alignment. Next please. Okay, here see here now pipeline score below pipeline. What he did, skewness, some especially with direction of. I will show you next slide in Flume. Okay, next please. Yeah, this one and techniques. Yes, here see this one score below pipeline. This mean 2011. This one see pipe. Then later on he need to operate. And many researchers have done already research. So what he done? Skew means 10 degree, 20 degree like that. This pipe. So he done all 4 years in this lab only. His PhD. Then he produced good papers, one or two papers. One is neural computing, and also in Journal of Hydrology, one paper he produced. Okay, next please. I think. Oh yes, that's what about my today's lecture. I think almost finished. So several applications. Here only few I am showing. Many other papers, culvert score and also pipeline score, and also peer score and abutment score. As a single author, I also produced using Professor Day data. Okay, so I am not discussing today. Abutment score and another papers. Another student Reza for Muhammad Iranian student have conducted that work. Okay, I hope I finish in time on time. Thank you very much for your patience.
Thank you, sir, for your wonderful and informative session. Now the platform is open for question answer session. So if any of the participant would like to ask, you can unmute yourself. You can also write the question in the chat box.
Yes, sir. I will share many papers.
Okay,
Almost
okay, sir.
same means three structure dimensionality. Yes, yes, please.
Okay, so I think there is no as such questions from the participants.
Okay.
If anybody would like to ask, you can unmute it. You can write in the chat box also.
Yes, sir. Sir. No problem. Later they can email also, sir. No problem. Here already 3:15, sir. 15 a.m.
Yes, yes,
No
yes, yes.
problem. I
That's why,
always.
I message. Okay, so I think if
Thank
anybody
you,
has
sir.
any
Thank you
kind
so
of
much.
okay, so anybody has any kind of query or any questions, so I will share the email address of Professor Azamathulla sir, because right now in his country the timing is 3:15 a.m. So in midnight he is delivering
Yes,
the
sir.
lecture. That's why we are not taking much time. So once again, on behalf of Civil Engineering Department and organizing team, we would like to thank for accepting the invitation, and as well as thankful for delivering such an informative session related to the Scour and the soft computing. What are the various applications in the soft computing? So thank you so much, sir.
Thank you very much, sir.
Thank
And
you.
a good day. And thank you again, Dr. Sarita Madam, and sir, and Principal Sir, and you, and Dr. Haresh. And also, I wish you great success. And to your college, especially inviting me, I'm very honorable to. Thank you very
Thank you,
much.
sir. Thank you.
Thank you, sir.
Thank you.
Thank you very much.
Okay.
Good night. Sorry, good day, sir.
Okay. Good night. Good
Sir.
night, sir. Thank you. So herewith we are ending the
Thank you, sir.
first.
Thank you, sir,
Okay.
Dr. Mehta.
So herewith we are ending the session one of day one of STTP. Now we will meet at 1:30 sharply. And as I put the message in the group yesterday that those who want to install the software of Hackers and QGIS, please install it, right? Because we are not going to uh, learn the whole software. I will show you the exercise using the Hackers software, and one of my research scholar, he is going to show you the application of QGIS in various works, right? So if faculties or participants are interested to learn, then you can install it in your laptop or the desktop, and accordingly you can do the example or do the exercise along with me. Fine. So thank you so much for the active participation.